Okay, so today we are going to see about binary search algorithm. Okay, so what is binary search? First questions arises like why binary search, right? There are linear search already available. Okay, so why not linear search? Why binary search, right? So first major thing why do we need actually binary search is, right, like if you want to try to solve any question, or suppose you have an array, simple array like 2 9 5 6 17 1 8. Okay, suppose you have an array. Okay, and you have to search 1 in the array. Okay, then if you apply linear search, then it has to be run from the start of the index and go until the last index, right? Getting the point? But in binary search, in linear search, it is trying to search from the starting index and going until the last index. Okay, so it can happen that it has to be run from 0 index till n index. There may be possibilities. Okay, so rust time complexity can be what? N. Okay, your rust time complexity can be n. Okay, so as we know that any developer having the main motto is to optimize the code. Okay, so that it can take less time complexity as well as less space complexity. Getting the point? Okay, so our main motto is what? Time and space complexity, right? Getting the point? Yes. So if you try to search through linear search algorithm, then it can take up to n times, right? But when talking about binary search, that's why we need binary search actually. So when talking about binary search, so in binary search, the rust time complexity, it can be n by 2. So basically half of n. Okay, getting the point? That's why binary search is better than linear search. But there are some certain criteria which it has to be followed. Okay, if you want to apply binary search, then your array should be sorted. This is the base criteria of binary search. Okay, array should be sorted. This is the base criteria. Okay, so basically if you find your array sorted, so if you find your array sorted, okay, so with just blindly apply the binary search. Okay, without any hesitation, just apply the binary search, because when your array is sorted, just binary search will be the most optimized algorithm. Okay, that's why we are learning the binary search. So how binary search actually work? So let's see the algorithm of the binary search. Okay, so for applying the binary search, first we should have the array of sorted. Suppose 2 3 4 5 6 8 and 9. Okay, so suppose you have to search number 8. Your target element is 8. Okay, your target element is 8. Then what you have to do? You don't need to search from start of the index and go traversing each step. Okay, and by comparing your target element with the index element, right? Without these things, we can apply binary search. And how binary search is work? It simply take two variables. It will take two variables. So first it will take two variables. First variable is start index. Okay, start index, it will starting index of start, it will be 0, right? And it will take end index, which will be nothing but your length. Okay, last index, right? Now after that, it will run the loop until your start index is less than or equals to end, till it will run the loop, and it will find the mid element. Okay, it will find the mid element. So middle, what will the value of mid element? It will be start plus end. Okay, start plus end by 2. Instead we can write start plus end minus start by 2. Okay, just because of, if there are, suppose if you have array of size, large number of size, right? If you are having array with large number of data, then if you try to solve, find the mid element by this formula, then there may be possibility that your integer limitations will exceed, maybe, because your int data type having some limitations, right? That's why we are taking it as a like that. Basically both will give the same answer. Okay, that's why we are taking start plus end minus start by 2. Okay, now after finding the mid element, it will try to search array of your mid element, whether it is less than equals to target, or your array of mid is greater than target, or your array of mid is equal to target. So basically each time binary search, it will try to find these cases. Okay, so suppose your first, so let me copy the array. Okay, just wait, I'm just copying the array. I'm just copying the array, just wait for 2 minutes. Okay, I'm not able to copy it, just wait for 2 minutes. Okay, just we're copying it and just paste here. Okay, so now we have find the middle element. Okay, what is the middle element? At starting, what is the middle element? Mid equals to what? Start plus end by 2. What is the starting index? 0, right? Last index, what is the last index? 0, 1, 2, 3, 4, 5, 6. So 0 plus 6 by 2, that is nothing but 3. So now your third index is 5. Okay, now it will try to compare your 5, right, array of mid, compare with target element. So it will try to find whether your array of mid is less than target. Okay, if your array of mid is less than target, that means your target element is greater than the middle element, right? That's why it will switch to the here, it will switch to 6. That means what it will do, it will switch your start index mid plus 1. Getting the point? It is shifting your start index from here to the 6. Now your start index becomes 6. Okay, and your end index is 9. It is same as it is 9. Okay, now it will check second condition. So you can see that we have the target element after mid element, right? You know that the target element is greater than the middle element, so that's why we don't need to search in the left part. Okay, that's why it is the time complexity of binary search is n by 2, because it is dividing your problems into sub problems, right? Now It is the first case. Second case, what can be second case? It can be your, if your array of mid is greater than the target. Okay, if your array of mid is greater than the target, then what can happen? It will switch to the left. What that mean? It's mean that your target element is lesser than the middle element. Okay, so it has to be available in the leftmost side, right? Okay, that's why it will switch your end variable to the left. That means what? Mid minus 1. Okay, and your third case can be, what can be your third case? Your third case, just wait, I'm just getting the issue, just wait. What can be third case? Case can be if your array of mid is equal to target, right? It can be possible, right? So if you find your array of mid element is equal to target, just return the mid element. Okay, return mid. Got the point? It is as simple as you can see. Okay, now just try to write the code. Okay, we will go to the VS Code and we will try to write the program for finding the target element of any sorted array. Okay, just wait, I'm opening the VS Code. Okay, now see, we have created an demo DS. Okay, now we will try to write the program for the binary search. So let's suppose we are writing the program static int binary search. Okay, we are passing an array and sorted array basically. Okay, and one target element, right? So just for your purpose we are adding -1. Okay, see, now first case what we have to write, you have to take two variable, that is start. What will the start? It will 0. Your starting index will be 0. Okay, and end index will be array dot length -1, right? Now just run the loop, while loop, until your start is less than equals to end. Just find the mid element. Int mid, it will be equals to what? Start plus end minus start by 2, right? Okay, so the moment you get the mid element, just try to compare with target element. So what can be conditions? First condition can be if your array of mid is less than the target element, that means your target element is greater than the middle element, so it has to be available after the mid element. Okay, so we will move our start index to mid plus 1, right? Now second case, what can be second case? If your array of mid is greater than target, what that mean? It means your target element, it has to be available left side of the mid element, so we will shift our end index to mid -1, right? And else what can be happen? Else your target element is equals to middle element. In this case, what will you do? You will just assign your, just return mid element basically. Okay, just return the mid element. Now your function will return middle element. Just call this function. Just call the function binary search. This is array, target element suppose 8. Okay, we are writing the array, basically sorted array. right? Suppose 2, 3, 4, 5, 6, 7, 8, 9. Okay, just save it and run it. You can see it is showing 6. Why 6? Because your target element, that is 8, is found at 6th index. You can see 0, 1, 2, 3, 4, 5, 6, right? You are getting the answer. Okay, so in this way you can find the target element of any element. Okay, this is the basic algorithm. This is basic problem, you can say basic program for finding any target element through the binary search. Okay, now we have done with normal binary search. Okay, now just try to solve one question. Okay, we are trying to solve the question. There are some questions. What was the question?